In this video, I'll show you how to solve the ALEKS problem called counting the electron shells in a neutral atom. This problem is going to give us the symbol of three different elements. It wants us to count up the number of protons, the number of electrons, and the number of electron shells for each one of these elements. So first of all, the number of protons is the number given to us on the periodic table as the atomic number. So to find the number of protons, we just need to simply find that element on the periodic table. Barium is located right here, and that number, 56, that is the number of protons in that element. Now for any atom, and this problem is telling us that these are atoms, for any atom, the total number of protons is equal to the total number of electrons. So for an atom, the atomic number is also going to be the total number of electrons. Nice. Now, for the number of valence electrons, the valence electrons are the electrons that are on the outer surface of the atom, and that is going to be a number, typically a number less than the total for most atoms. Now, the number of valence electrons is also given to us on the periodic table in the titles of the columns on the periodic table, the titles that have the A in the notation. So for this periodic table, I'm going to cross off these numbers that are not useful. They're distracting us. We're going to focus on the 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. These numbers correspond to the number of valence electrons for all of the elements in that column. Again, I'm dealing with barium in this problem. Barium is in column 2A, which means that it has a total of 2 valence electrons. Now, there is one exception to this rule, and that is over here on this side of the periodic table. Helium, this element only has 2 valence electrons, even though it is in column 8A. All of the other elements in this column have 8 valence electrons, just like we would predict, but helium only has 2, so let's just kind of keep that in mind if you get helium in your problem. Now, last but not least, it wants us to indicate the number of electron shells. That's going to be the layers of electrons around the nucleus, and the number of electron shells is given to us by the period number, the number that is the number of the row that the element is in, the horizontal row. So for barium, it is in row 6, period 6, which means that it has a total of 6 layers or 6 shells of electrons. Let's try this problem for Ra. Where is that located? Oh, it's right here. The atomic number for this element is 88. That means that there are 88 protons, and because it's an atom, there are also 88 electrons. It is also in that same 2A column, which means it also has only 2 valence electrons. And the number of electron shells for Ra, it is in period 7, so it has 7 shells. Last but not least, strontium, that's right here. This guy has an atomic number of 38, which means that it has 38 protons, 38 electrons. It's in the same column, so it has 2 valence electrons. It is in period 5, which means it has 5 shells.